When you look up at the night sky, it feels calm, almost peaceful. But what you are really seeing is a cosmic battlefield of extreme physics, violent explosions, and mysteries that stretch beyond human imagination. Every tiny point of light above you is not just a star. It's a massive nuclear reactor burning at millions of degrees. And beyond those stars lie planets, moons, comets, and worlds we have barely begun to understand. But to truly understand the universe, we have to rewind the time, all the way back to the beginning. The universe began 13.8 billion years ago in an event we call the Big Bang. Not an explosion in space, but the expansion of space itself. In its first fraction of a second, the universe expanded faster than the speed of light in a phase called cosmic inflation. After the expansion, as it cooled, energy condensed into the first particles, quarks, electrons, and neutrinos. These tiny particles combine to form protons and neutrons, the building blocks of atoms. Within minutes, hydrogen and helium nuclei filled the newborn universe. Then the universe entered a dark age. No stars, no galaxies, just endless fog. Gravity began its quiet work, pulling matter together over millions of years. Eventually, the first stars ignited, and the universe lit up. These first stars were giants, hundreds of times more massive than our sun, and they lived fast, burning through their fuel in just millions of years. When they died, they exploded as supernova, scattering heavy elements into space. Those heavy elements, carbon, oxygen, iron, would one day become planets and life. Galaxies began forming, pulled together by an invisible force. We now call it dark matter. Dark matter does not emit light, but its gravity shapes the cosmos. In fact, the most of the universe is invisible. Ordinary matter, everything we see, makes up less than 5% of the reality. The rest is dark matter, and something even stranger, which is dark energy. The dark energy is driving the accelerated expansion of the universe. And that means the universe is not just expanding, it's speeding up. If this continues, galaxies beyond our local group will one day disappear from our view. But when we zoom back in, the universe becomes even stranger. Inside atoms lies a quantum world ruled by probability, not certainty. Particles can exist in multiple states at once. This phenomenon called superposition. And entangled particles can affect each other instantly across vast distances. Einstein called it spooky action at a distance. Even today, we are still uncovering how deep the quantum rabbit hole goes. And then there are black holes, where gravity becomes unstoppable, formed when massive stars collapse under their own weight. At the center lies a singularity, a point of infinite density. Around it is the event of horizon, which is the point of no return. Cross that boundary and escape becomes impossible. Yet black holes may not be cosmic destroyers after all. They slowly evaporate over unimaginable timescales through Hawking radiation. Some black holes are billions of times more massive than our sun. Nearly every galaxy, including ours, hides one at its core. So the universe is not static. It's dynamic, violent, and constantly evolving. Galaxies collide and merge over billions of years. Stars are born in glowing nurseries of gas and dust. And somewhere in this vastness, life emerged. On at least one small planet orbiting an ordinary star. Life evolved, became conscious, and began asking questions. Questions about where we came from and where we are going. The secrets of the universe are written in light. By analyzing starlight, we decode the chemistry of distant suns. We measure their motion through subtle shifts in color. And through these methods, we map a universe too vast to travel. Yet for all we have discovered, we have only scratched the surface of cosmic truth. Because the deeper we look, the stranger reality becomes. The universe may even be one of many, part of multiverse, Entire reality is possibly governed by different physical laws. Or perhaps our universe is holographic projection, a three-dimensional shadow of deeper information encoded on a distant boundary. These ideas sound like science fiction, but they are rooted in real equations. Mathematics has become our telescope into the invisible, and each generation pushes the boundary a little further, from Galileo's lens to space telescopes orbiting beyond Earth's atmosphere. We now peer back nearly to the dawn of time itself, and what we see is both beautiful and humbling. Because in the grand scale of cosmos, we are incredibly small, yet we are also the universe becoming aware of itself. Atoms formed in ancient stars now form brains capable of understanding stars. That may be the most astonishing secret of all. The universe is not just out there, it's within us. And as long as we keep asking questions, the secrets will continue to unfold. Because exploration is written into our nature, and the next discovery could redefine everything we think we know. A new particle, a new force, or a completely new understanding of reality. The universe still holds countless secrets, and we are only at the beginning of the journey. So tonight, when you look up at the sky, remember this. You are standing inside one of the greatest mysteries you ever known. And the deeper we investigate that mystery, the more we realize that universe is governed by a surprisingly small set of fundamental rules. 4 fundamental forces shape everything we see. That is gravity, electromagnetism, and the strong and weak nuclear forces. Gravity sculpts the cosmos on the largest scales, binding planets, stars, and galaxies together. Electromagnetism governs atoms, chemistry, light, and even the signals in your brain right now. The strong nuclear force binds quarks together, forming protons and neutrons at the heart of the matter. And the weak force allows particles to decay, making nuclear fusion in stars possible. Without this delicate balance of forces, the universe as we know it simply would not exist. Einstein described gravity as the curvature of space-time itself. Massive objects don't pull on space, they bend it, and everything else simply follows the curves. But at quantum scale, space-time may not be smooth at all. It could be foamy, turbulent, constantly fluctuating at unimaginably tiny distances. Reconciling gravity with quantum mechanics is one of the greatest challenges in physics. Some theories propose tiny vibrating strings as the fundamental building blocks of reality. In string theory, particles are simply different vibrational notes of these strings. Others suggest space itself is woven from loops of quantum geometry. We don't yet know which path is correct or if the answer lies somewhere else entirely. Meanwhile, astronomers search the skies for clues hidden in cosmic radiation. The cosmic microwave background is the afterglow of the Big Bang itself. Tiny fluctuations in that ancient light became galaxies billions of years later. By studying these patterns, we read the universe's earliest memories. We have also discovered thousands of planets orbiting distant stars. Some may have oceans, atmospheres, even the conditions necessary for life. The question is no longer if planets exist, but whether we are alone. Radio signals sweep across space as we listen for a whisper from another civilization. So far, the universe has remained silent. But silence does not mean emptiness. It may simply mean we have only just begun to listen. The universe is vast beyond comprehension, yet bound by elegant laws. It began in fire, expanded through darkness, and evolved into unimaginable complexity. From quarks to galaxies, from stardust to consciousness. And perhaps the greatest secret is this: the universe is still unfolding. New stars are igniting, new planets are forming, and somewhere right now, new questions are being born. Because curiosity is the engine that drives discovery. Every answer leads to deeper mysteries waiting beyond the horizon. The secrets of the universe are not hidden to keep us out. They are hidden to inspire us to search. And as long as humanity keeps looking up, The universe will continue revealing its story, one discovery at a time.